Okay, the next topic that we are going to study for a few lectures is classification problems. Okay, what is a classification problem? So far, we've been looking at problems where the outputs in some data set are real valued or continuous valued, right? In classification problems, the output is discrete valued. So what's an example? Imagine you have a picture. Maybe this is a silly example. Imagine you have a picture and you want to say whether the picture has a cat or a dog. In other words, you have one of two options, cat or a dog, and that would be considered discrete valued. Um, and this is a classification problem, right? And you can imagine any number of engineering slash science questions that have the same classification flavor, where you are trying to pick among one of two choices or 10 choices or 10,000 choices. Here's an example. Given a structure and some external forces on the structure, will the structure be able to withstand the forces? Right. So imagine you're devising an assistive device for a person, maybe a prosthetic device, and you know typical forces that that prosthetic device will need to withstand, and the question is, will the device be able to withstand those forces? Okay, that could be considered a classification problem. Given a sound, some audio information, what is the word, or is there a word in that sound, or what is the word? And this is now is going to be a one of many thousand choices, because typical languages have many thousands of words. Given a robot control algorithm and some parameters for the control algorithm, will the robot succeed in its objective or not? Right. So that could be an yes or no question. Given some data from some car's sensors, for instance, looking at a pedestrian at near some intersection, you can ask the question, based on the information that you have, will the pedestrian cross the road or not? That could be yes or no question that might decide how the car wants to react, or you as a driver wants to react, right? You can have any number of questions like this. Will it rain today, or the road slippery, which might be related to whether it will rain today or it rained today. Do we have enough fuel to reach the destination? In any case, you can imagine a million questions like this, and they're all classification problems. Of course, you can imagine some of these questions could be converted into outputs that are continuous, where instead of saying will it rain today, you can try to express the probability of rain, which in fact many weather stations do provide. Instead of saying are the roads slippery or not, maybe you can try to estimate the friction coefficient of the roads. So you're trying to convert it into a continuous sort of output problem. But sometimes the natural framework is discrete, but sometimes the natural framework might be continuous, and sometimes maybe both, right? So we will sort of discuss those issues, and those issues will be application specific. But nevertheless, there is this somewhat distinct class of problems which could be considered different from the continuous output problems, and these would be called classification problems. Okay. Now, how do you build a classifier? So an object that classifies would be called a classifier that answers these questions with discrete outputs. One approach is the exact same approach that we've been using so far, which would be called supervised learning. In other words, we have lots of data with inputs and outputs, but the output is not a continuous variable, but it's a classification. So imagine you have a million pictures, and they have been classified into cats or dogs. So you have data of that flavor. And then you can try to build a classifier, basically a function that takes the input-output data and then learns that transformation, right? And we will see that there are a number of different methods for building these kinds of functions. The first one that we will look at is called logistic regression. A more popular one these days is called neural networks, or deep learning, I guess, is a version of neural networks. But it turns out that these methods are very closely related. In fact, could be considered special cases or variants of each other. So we might talk about that as well. Okay, so that's the end of this little video, and now we will look at a few simple examples of how to solve these classification problems.